2/5 plus 1/5? Using your new little manipulative that you have, it looks just like this. I'm going to give you about 2 minutes so you can turn and talk to your neighbor. I want you to show me what that problem would look like when you solve it on your number line. Okay, so you have about 2 minutes, and that time's going to be up. So, talk to your neighbor. Okay, as I was walking around, I noticed a lot of people starting with the number line, which is what you're supposed to do. And how do you know how many numbers to put on the number line? How do you know? What do you have to look at to know what number you're using?
The denominator.
You have to look at the denominator, which is the
5.
bottom number, and it's 5. So you start with 0, right? 0 out of
5.
What happens to the numerator as we move along?
For some reason, she said it. It cost her.
Okay. Mandy? It gets bigger. How does it get bigger? Okay. How would you say, like, when you're saying it gets bigger? How big is it getting each time? Good. It's going in steps of 1, right? So we have 1, 2, 3. Now, remember we talked about how now that you're in 5th grade, that your numbers are going to go past the 5, 5 probably, and they're going to just keep moving, right? What happens when we get to 5, 5? What happens when the number is the same on top and on bottom? Brianna?
It equals 1 whole.
It equals 1 whole. Okay, so now what do? We've done our number line. We've gone up to 1 whole. We may have to extend it at some point. I'm not sure yet. I won't know until I solve the problem. Ariana?
Since it says 2/5 plus 1/5, you're going to make a little semicircle thing from the 0/5 to the 2/5, and it says plus 1/5. You're going to do it one more time, and you're going to land on 3/5.
Okay, so if we look at our number line, how it goes up by numbers, this one says we go up 2, so yeah, we're going to start 2, and what's this going to have up here? Plus
2/5.
2/5, and then what are we going to add to it?
You're going to add 1/5, so you're going to make another one, and over it you're going to put plus 1/5.
That's 1/5. So we did that. Now how do we know what the answer is? How do we know what the answer is? Grace? Any mistakes?
You know, it's 3/5 because that's where you landed, and there's nothing left to add more.
Okay. So if you want, a way to help you remember is every time you get to the very last one that you're doing, you can just put an arrow. And that tells you that that is going to be your answer. Let's look at a little more complicated problem. We'll go over that. And then I'm going to introduce you to, oh, brother. Wouldn't you know it? Then I'm going to introduce you to something new. Something else is kind of cool. You know, I think the reason I think a lot of this is cool is that I struggled so much with fractions when I was growing up, especially 5th grade. And when I see these steps, I think, oh my goodness, if I could have just learned it this way, because fractions were so hard for me. So you didn't actually really pay attention to these steps. Yes, ma'am.
Why can't you just take 2 plus 1, and since you know that 5/5 is the same as 5/5, you can just say 3/5.
But do you know what it looks like?
Yes.
Do you know what that looks like in your head?
Yes.
And would you know what it looked like if it had different numbers on the bottom?
No.
No, know. So that's why today, see, it keeps getting bigger and bigger. So you've got to learn the easy way first, and then you'll know how to do the hard stuff because it just builds. So you guys just hang in there. I mean, I know all the old tricks, but like I said, I always struggled with fractions, and if I would have known the pictures and had the pictures when I was younger, I would have probably understood it a lot better. So I'm going to give you another problem to try out, and then we're going to move on to brighter things. I don't want to do that one. I could do that one, but I don't want to because I want to stay on my number line. Okay, I'm going to give you about 2 minutes again. I want you to work with your neighbor to see how you would put that on the number line. So when I walk around, I'm going to be looking for numbers on your number line. And I want to see your answer. So 2 minutes, and then we'll be moving on. Okay, good. So what we're going to do is, like you just said, we're going to just start. We know that we have to get to 9/4, right? So we start 0/4, 1/4, 2/4. I already know myself. And we know that every time, like Jillian just said, we know that every time we get to 4/4, it's 1 whole, right? And then what happens to my numbers after that? What happens to my numbers after that? We're going to draw this on your board. Okay, so you start counting again, and then, so 5/4 would now be what?
1/4.
And then
2/4, 3/4, 4/4, 2 holes,
okay, so now we are at 4/4 again, and now we have
2 holes,
2 holes, and then we start over again, right? Which 9/4 will become 1/4. So when all is said and done, we see that to get from here to here, we go 1 hole plus another hole, right? Plus 1/4. And that looks like this, 2 and 1/4. So 9/4 is the same as 2 and 1/4. Raise your hand if you can tell me what 9/4 is. What's the term that we give that type of fraction? Does anyone know? This might be something new. I don't know if you learned it last year or not, but I know we haven't talked about this year.
equivalent fraction.
No? Well, they're equivalent. Yeah, those two numbers are equivalent. But what would we give the name to this fraction right here, 9/4? What do you call that?
Improper fraction.
It's improper. Because, no. Why would you call it improper? Improper means you're naughty. You're doing what you're not supposed to be doing.
Improper fractions is like the numerator is bigger than the denominator.
Exactly. The numerator is bigger than the denominator. It would be like the time that I cleaned my niece's room up, and because she had said that she cleaned it, she lived with me, and that was not my definition of clean. It would be like me shoving everything in the garbage bags, and the garbage bag exploding because there's too much stuff in it, right? So right now, if we had 4 boxes, can we shove 9 things into it?
No.
No. It is improper. It's wrong. It's too small. So in order to make it the correct way, because you can't leave a fraction as 9/4, you can't leave an improper fraction. What do I need to do? What is that second number called? Okay, it's equivalent, but what is this thing called? When we see a whole number with a fraction, what's that called? A mixed number. Because we have a whole number and then we have a fraction, a part of a number. Pay attention to the number lines, guys. They'll come back. You need to know what you're doing. So today we're going to talk about adding fractions, and that's lesson 3. So look at lesson 3, problem set. And I did it again. What I need to do is save this. Almost like this. There we go. Yeah, you have on your desk this chart. We have the numbers 1/2 plus 1/3. So at the top, I want you to just write 1/2 plus 1/3. Well, we have a problem. You can't just draw on your number line because what would you put? 2 or 3? I mean, you can't just do it on your number line anymore, can you? No. What is it called when the two denominators are different? Does anyone know? Anyone know? You guys ever worked with uncommon denominators before?
When they're the same, they're
When they're the same, they're called common. And when they're not, they're uncommon. So, this is, I kind of like to look at the way they do it, and then I kind of tweak it a little bit. Some of you guys go kind of out of control with your coloring, so I've thought of a different way to do this. Look at your denominator. The first one in the problem is how many you're going to go over. So I'm going to go over 2 boxes. I'm going to go over 2 boxes. And how many do you think I'm going to go down? Ruth?
3.
Okay, I'm going to go down 3. 1, 2, 3. Now I'm going to do that twice because I have 2 numbers in my problem. Over 2, down 3. If I draw a line right like that, what fraction at the top do you think I'm going to represent in my first box? 1/2 or 1/3? I'm going to represent 1/2 because how many boxes do I now have total? 2. Try not to pay attention to the lines. I try to make them light for you guys so that when you write over them, you'll be able to see them a little better where you've written. On the second one, I'm going to go sideways like this. And now how many boxes have I drawn on that one?
6.
No? Have I drawn? Not how many boxes do I have, but how many have I drawn?
2. 2. 3. 3.
3. See, look. 1 strip, 2 strip, 3 strip.
I was trying to say 3.
Okay. So when it says 1/2, you got a lot of people in that one, and they're going to be like, later, like, I don't know what to do. I have 1/2. How many of these I gonna color in that I've drawn? How many total pieces?
Now,
A half. Here's what you need to do. Instead of coloring all over it, where you're not going to be able to see lines when we're done, I want you to put dots. So that whole half now has dots in it, right? One dot in each of those, we'll call those imaginary boxes for right now. What do you think I'm going to do on this side? What am I going to do over here? What am I going to do? We're not coloring it, we're putting dots.
Since it's a third and there's 3 boxes, we're going to have to put one box or one dot in a box.
Okay, and these are my boxes, right? So I'm gonna I'll make sure that each of my imaginary boxes has a dot in that rectangle. So how many dots do you now have in the first one?
3.
How many do I have in the second?
2.
2. This is where life becomes beautiful. Now I'm going to draw that box one more time. So over 2, down how many?
3.
Over 2, down 3. But this time, when I draw it, I'm going to draw all the lines, just like this. Maybe you draw all the lines just like that. How many dots did I have in the first one? Jessica?
3.
3. So I'm going to come over to this. I'm going to put 3 dots. And how many dots did I have in the second? 2. So I'm going to put 2 dots. One half plus 1/3 equals, what do you think? What do you think? Look, what do you think? How many total boxes do we have now? Right here. In this one, how many total boxes? We have 6. Remember, the denominator tells how many total we have. And then how many dots do we have? 5. And the 5 says how many out of the 6 we have. So 1/2 plus 1/3 equals
5, 6.
5, 6. I'm going to leave this up here because I want you to erase your board. I'm going to have you try another one with your neighbor before we move on to a little more complicated. I'm going to have you do 1/3 plus 1/5. Okay, so you look at your 2 bottom numbers. Those are your denominators. You look at your first one. You're going to go over 3 and down 5. So now what do I do? Anthony, do you know what I do next?
First, we cut into 3 pieces.
Huh?
The first box we cut into 3 pieces
Okay, the first one we're going to cut into 3 pieces. Why are we cutting it into 3 pieces?
because it's 1/3.
Okay, because it's 1/3. Remember those lines in the back right now are imaginary until we fill them in. And Miss Morgan, do you know what I do on the second one?
Well, the second one, you put 4 horizontal lines there.
And why am I putting 4 horizontal lines?
Because then that would be 5. If you put 5, then it would be 6.
Okay. So right now we have 1, 2, 3, 4, 5 strips. 1, 2, 3. If I wanted to make this one whole, what would that look like?
You put a dot in full strip.
In every single one, so my fraction, what would that look like? No, what would my fraction look like? If I wanted to make it one whole, what would it look like? What would it look like?
It It would have dots in every single box.
You're gonna have dots in every single box, and the number would be
3/3.
3/3. But this time it's 1/3, so we're gonna have only how many of the strips colored in? 1. Remember, we're using dots because once you start coloring, you get a little ambitious, and then you can't see your lines to see how many total boxes you have. And let's see.
Five dots in the second box.
How many fifths do I have? Okay, I have 1/5. So remember, this is 1, 2, 3, 4, 5. How many of all those strips combined do I have that I'll show you? It's gonna look like this, remember? So this plus that equals, now what do I need to do? Jackson, you know what I need to do?
No. So paying attention to make sure we know what to do.
Okay, pay attention.
Now you're gonna go into the box.
Draw another box. How big's the box gonna be? 3 across and 5 down. 1, 2, 3, 4, 5. And what do I do this time? What do I do this time? Joanna, what do I do this time?
You're gonna do all the lines.
Okay, all the lines. And 17. How many total dots will I have?
You will have 5 going down and 3 up the bottom.
Okay, so 1, 2, 3, 4, 5, 6, 7, 8. One third plus 1/5. Everybody, what's it equal?
8 15s.
How'd you know it was 15? Why did my number just change to 15? Greta, why did my number just change to 15?
Because if you count all the boxes, there's 15 and 8 of them have dots in them.
Okay, so if we were talking, remember I use those words common and uncommon denominators? If we're talking about common denominators, what do you think a common denominator between 3 and 5 would be? What number would they both share that would be common? Here's something new out to you. Let's see some puzzle. Anyone want to take a guess? You didn't hear my full question.
I was trying to think of, I think I got an answer.
Now wait, are you trying to do alter? You can't do other ways. Remember, we've had this talk. Throw out everything you've learned. Samantha, you know what I'm talking about. She came to me yesterday. But Miss Hepburn, I know how to do this way. You can't do that. Okay, Alexis. What would the common denominator be that 3 and 5 share?
15.
Yeah, 15. It's a number that both of them go into, and when you combine them, you find out that you have 15. Got it? Because now we're going to add on to it, and hopefully my 3 people that I keep seeing not focusing at all on me right now, hopefully they're getting something, because I'm a little concerned you're not going to know at all what to do. So. I want you to try now, I do have people that have been asking me questions like the last problem on your homework last night. I had people ask me about that when they came to me. What did I, and the ones who were having problems, what did I not see on their paper? What do you assume that I didn't see on their paper when they're trying to work out a word problem?
Number line?
Number line, and what else?
Anything? Like they didn't even try?
No, they were trying. They had numbers everywhere. But what did I probably not see?
The ending sentence, like, Natalie saw blank.
Yeah, I wasn't seeing that anywhere because they didn't even have it solved yet. What do you think?
Maybe like all their problems, like all of them, like it was like coming together so you couldn't even know what they were trying to do.
Nothing.
The answer
They didn't have one of these boxes. They didn't want to add it.
What do you need to use when you do word problems usually? What do you need to have on your paper so that you can use and that you can use to help you efficiently and effectively solve this problem?
I think it's a diagram.
Yeah. I saw no pictures. Remember? Our numbers have pictures now. They're not just like out there abstract things. They actually have pictures associated with them. So if you come and ask me for help on a word problem, I need to see pictures. Okay, and I'm going to make you start showing me your pictures before I will help you. Because you need to show that you're making that step towards drawing it out, thinking through it, and then solving it. You will have word problems on tonight's assignment. Just a little FYI. Look at the homework. I think they're being nice to you tonight. I don't think we're going to have any whole numbers, but we have A through F. We'll be solving the exact way that we just solved them. And then a word problem. Oh my goodness, it has a fraction in it. So it says Rajesh jogged 3/4 a mile and then walked 1/6 miles to cool down. How far did he travel? What's the first thing I need to draw?
Number line to figure out pictures.
Pictures. So we probably want a
Tape diagram.
tape diagram. Good job. And so we would draw our little tape diagram. It's asking us how far did he travel. So do we know what this total amount is? Do we know what the total amount is? No, so that's our question mark. That's our unknown. We don't know that yet. It says first he jogged 3/4 mile. So let's just do it like this. I'm not counting boxes or anything, so don't do that. Make sure you're drawing this. You can draw this on your paper under homework number 2, unless you really like leaving here and solving it by yourself. So this is how far he jogged. And then he walked 1/6 of a mile to cool down. How would I figure that problem out? How would I figure that out? How do I figure out how much this equals? How much does this equal?
We use these our homework tonight when we're at home, or does it have to be in class?
No, you can use those at home. You can use those at home, but on your word problems, I want to see tape diagrams and things, okay? To see how you set it up to solve it. but you can solve the rest on here. So 3/4 and 1/6. How do I solve that problem? What operation do I need to use? Draw boxes, but what's my operation? Add, subtract, multiply, divide. What? Add them. 3/4 plus 1/6. Okay, so your assignment is all of homework, including the workroom, and make sure you draw and take diagrams. Now, I'll give you, since this is a new concept, instead of going to the computer lab after today, we'll come back here and you can work on it, and that way I can help you if you need it. On